how does this relate to base conversion? I mean, okay, let's see. We got $132 bill, 016, 08, 14, 02, 11, $1/2, and then $1/4. Well, guess what? We just ended up with a binary number. Not only is it a binary number, it's a binary number that has, I guess, binary point, not decimal point anymore, right? And that's how we interpret, that's how we convert the base, okay? You're just really doing the same thing that we have been able to do with money, except in this case, these are very easy to do. Go ahead.
The 2 in parentheses just means that you're
base 2. Yeah, it's the 2 in parentheses means this is a base 2 number, because without the parentheses, 2, some people can look at this as 100,000, 101, and 11 of a thousandth and a hundredth. Yep. So we know base conversion already. Okay, fine, good. So remember earlier I said an integer has up to 32 or 64 bit. Now those are pretty huge number to deal with. So for the purpose of discussion here, let's say we're only dealing with 8 bit. Okay, 8 binary digits to store an integer. Okay, so that means a number can range from this to base 2. Well, 0 is 0 in any base, but I just want to make it very clear, to 1111, 1111 in base 2. Okay, and let's not think about the values or the quantity they are representing. How many of these things do I have? The next one is 0000, 001, and then the next one is 0000, 0010, and so on. So how many patterns do I have when I can go from 00000000 to 1111, 1111? It's 2 to the power of 8 of combinations. Am I doing okay so far?
Yeah.
Okay. So we have 256 distinct bit patterns when I'm given only 8 bits. So how many integer values do you think I can represent using an 8-bit integer? 256. Right? Okay. So the next question is, how do we store those numbers? I mean, positive and negative. How do we store negative numbers? That's a topic for CISP 310. So I'm not going to go over that in this class, but it is enough to talk about just a little bit here. I can't really do it this way using this tool. I'm going to use a different tool for this part, and I'm going to use Inkscape for this. I think I should convince the department to buy me a Samsung Note, as a tablet, so I can actually do this whole thing easily. No, not brown. Oh, this is the wrong tool to use. Okay, keep that. Okay, what I want to do is to draw a circle. And I want to get rid of this. Green, black. And increase. Make it bigger. All right. So we got a circle here, and that makes this a solid line. And that's what numbers are. Okay, when you look at the values that can be represented as an 8-bit number, it's a full circle. So what do I mean by a full circle? Well, let's pick a spot here. Okay, so we'll pick this spot here. That spot, let's say this starts with a value of 0. And you will see, okay, so the next slot has a value of 1, 2, 3, 4, and so on. On the other side, we got -1, -2, -3, and so on. Does that make sense? It's kind of like a number line, except it's warped, right? But unlike a number line, which can go indefinitely on one side and go indefinitely on the other side, this is a circle. They will meet at some point. So the question is, when do they meet? When I keep increasing the number, it will actually meet the most negative value. The most positive value will be right next to the most negative value. So in this case, as it turns out, the most positive value that you can represent using 8-bit or 8 binary digits turns out to be 127 as a base 10 number. And the most negative value you can represent is negative 128. Okay. Are we doing okay with this picture? Okay, so the values that we can represent, yes, go ahead.
The reason why it's negative or positive 127 is because 0 is sort of considered a positive number then?
Because 0 is considered a non-negative number.
Okay.
Yeah. So in other words, if you chop this pie in 1/2, okay, let me use the tool to chop it in half. This half are non-negative, and this half are the negative values. How many non-negative values do we have? 128 non-negative values, because we are counting 0 as non-negative. How many negative values do we have? From -1 to -128, we have 128. So this is an even split. Okay, we have 1/2 of it representing non-negative numbers and 1/2 of it representing negative values. All right. So when you're incrementing something, you are turning the wheel, basically. Okay. So let's say we have a little marker that indicates the value of the variable. So I'm going to use another thing to indicate that. Okay, so I'm going to use a rectangle to indicate that. This time out. All right, so this is my indicator of the current value of the variable. I'm going to use a rotate tool to rotate it. Okay. All right. So let's say this marker does not change its position. Instead, we rotate the wheel to indicate its current value. Is that okay? All right. What does it mean to increase the value of a number? Which way am I turning? Clockwise or counterclockwise? It's counterclockwise. Because when you rotate the wheel counterclockwise, then this thing, which does not move, will be pointing to a larger value. To decrease the value of the variable, we'll be turning the wheel this way. Okay? So the next question is, what if we are right at the borderline? Okay, so to do this, I have to, okay, let me see if I can do it conveniently. So I'm going to put this one a little bit out and select this entire thing, and then rotate this entire thing. Yay! Oh, it's changing the. Oh, I see what it's doing.
It's not really simple.
Okay, let's try this. Object. There we go. It's still shifting the size. I'm trying to do just a simple rotation. But without changing the size. Yep.
You need to have a circle to go on getting closer.
Because the selection is a rectangle, right? It's trying to maintain the rectangle perspective. Okay, this is what I do. Make a bigger circle. Make a circle that encompasses everything.
It's still kind of a rectangle.
No, I'll fix it. It only has to be approximate, right? It doesn't have to be exact. Object, group. I think this time it will work out okay. Yay, well. What am I doing wrong here?
It's an oval. It's an
oval.
oval. It's not a circle.
Hold the shift key while you draw the circle and it'll make an actual circle.
Hmm?
Yeah.
If you hold the shift key when you draw the circle, it will make an actual circle.
Yeah, you're.
It doesn't look like. Oh, you know what? I know it doesn't look like an oval to me, because this is a wide screen, so it's already.
Oh.
Yeah, so that's why. Okay. Well, in that case, I got an easy way to fix it. You know, I just need to strong arm it to think that it is. Yay! Because from my perspective, it's already a circle. It's like, I know it's not perfect, but it's pretty close to a circle. And then I look at that going, no, that's not a circle. All right, so that's fine. All right, fine. We got it fixed. All right, so this is, from now on I have to look at the monitor instead, the screen. So let's say we are rotating this, and we are here, okay? What happens when I add 1 to 127, which means counterclockwise rotation by 1 click? It becomes negative 128, right? And the same thing happens, in the other direction. If this thing is already pointing at negative 128, if I subtract 1 from negative 128, it becomes 127. Okay? Which is kind of strange, because the most negative value, if I subtract 1 from that, it becomes the most positive value. But that's exactly what's going to happen when you write the same thing, when you perform this kind of operation in C and C++. Okay? So that really goes back to the question of, what about this program that we had here, and we keep subtracting 1, and there's 2, right? 2 is over here. Well, if you keep subtracting, you're rotating this, in a clockwise manner, click, 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 right? So let's see what happens when we, rotate it clockwise, and we'll put everything back to where it's supposed to be. So we started off with 2 to begin with. Okay, so this is where we start off with. According to this program, it is initialized to 2, and then we perform this step here, because I cannot skip that step, because it's a post checking loop. I perform the operation before I ask the question, when do I stop? So I perform this step here, and it becomes 1, right? And then I go back to my algorithm. It asks the question, is x2? In other words, is the marker pointing at 2? No, it's not. It's pointing at 1. We go back and we say, okay, let's subtract another 1 from x here, which means in this case, they're rotating it to 0, negative 1, negative 2, negative 3, negative 4. And it keeps rotating in a clockwise manner, right? And guess what? At some point, it's going to rotate all the way to negative 128. Negative 128 does not equal to 2. We have to go back and subtract 1 again. But guess what? This time when I subtract 1, it becomes the most positive value that I can represent, which is 127. And then becomes 126, 125, da 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 da. And at some point it will go back to 4, 3, 2, and then the algorithm will ask the question, does x equal to 2? Yes. It's time to get out.
Oh wow.
Yep. So this code here, which should be an infinite loop, would actually get out in C and C++. In Visual Basic, it would actually generate an error and say that the integer value is out of range. Once you get it down to negative 128 and you try to subtract 1 more,